Thank you for the introduction. So you've had 3 days telling you about the joys and benefits of ERTMS. Maybe I'm about to spoil the show by saying there are things you need to be careful about to make sure that you can continue to get the benefits from ERTMS and ETCS. I'm not going to tell you about. So we're just going to move on to the next slide. So I'm not going to say any more about Alstom's global footprint. It doubled this year on the 1st of February with the acquisition of Bombardier. And from my point of view, my obsolescence challenge doubled with the acquisition of Bombardier. And my challenge today is the convergence of the systems from Alstom and Bombardier, so that we'll be implementing a single obsolescence management process and a single obsolescence management system throughout the business. It's worth saying, I think, given the numbers that you see, we were 35,000 people in Alstom before the acquisition, and we've trained 700 of those Alstom people in obsolescence management in our basic course run through Alstom University in obsolescence management. I think that percentage of employees is a good one. We now have to double the number because we have double the number of people. I'm not going to say anything about Alstom's ERTMS ETCS solutions. There are other people much better qualified than me to talk about that. So let's move on. So I normally start this presentation by telling you about 1993 and when the US military decided they would move from military grade components which were designed and built for long life cycle industries such as military, aerospace, etc. And they started to use commercial off-the-shelf components. And in a way, you could say that was the start of the modern world of obsolescence, because as soon as that happened, then the long life cycle industries like rail, like aerospace, became tied to the life cycles of consumer products, and so the mobile phone life cycle. I don't know how many of the mobile phones you've had, but I guess I've had one every 2 years since about 1996 now. So there's a big pile of e-waste somewhere caused by my use of mobile phones. That's what I normally say. I got this information last week, which I think says we're moving to a new level. So to give you a little bit of background in the world of electronic component obsolescence, the chip manufacturers, the people who design the chips and are continually upgrading their designs of chips to make them smaller and use less power, and all the things that give us smaller and better mobile phones and other home devices, have moved out and no longer make their own chips. The cost of setting up what they call chip foundries, so the factory where the chips are made, is so high it's in the billions. As we go to the fine and ultra fine pitch microprocessors and use of silicon, they can't afford that. So there are now 4 global companies who are the manufacturers of everybody's chips. So what you see here is an announcement from Global Foundries, which is one of the 4, to NXP, who are the designer of the chip, of the microprocessor we're talking about here. And it basically says, to respond to the unprecedented demand for semiconductor supply, our foundry partner, Global Foundries, has given NXP notice to end of life the C45S technologies with last wafer by in October 2021. So we had 6 months notice of this. And they give some good reasons why they're not really interested anymore in the business of NXP and their C45 and C90 technologies. And NXP haven't even had an option in this. NXP was simply told that in order that Global Foundries can make lots of money out of the automotive industry and electric cars and the rest of the demand for electronic chips, they will stop making this rather annoying product that they were making for NXP. And you can see further down, it says it's a unique technology. It will not be, due to the unique raw materials and timeline for starts, this date cannot be extended. So there will be a last manufacture of the wafer from October this year. So if you were a rail manufacturer who'd put this into your product, you had options and repeat orders and tenders that you were putting in to build systems, and whether it was a signaling system or rolling stock to last for the next 10 years. Suddenly you have to decide how many you need to buy for the next 10 years for your production. So you have to work out which of those contracts you're going to win and which of the options that the customers are going to make will be exercised. And then you have to work out how you're going to support the market already delivered, the install base already delivered, and the install base that is yet to be delivered for 30 to 40 years after that. So I think in a nutshell, you can see why we have a small problem with obsolescence in the rail industry. So moving back in time a little bit. So what is obsolescence? So this is Shrewsbury signal box. It was commissioned in 1903. It has 180 levers, of which 90 are still in use. But relevant to what we're talking about today, it's recently had a refurbishment, £250,000, which I think for all of those of you who work in the signalling industry will know that doesn't buy you very much interlocking or signal equivalent units. And in fact, the 250K has been to refurbish the fabric of the building in order to keep it usable and operational and in good condition, at least until 2030 and potentially until 2050. Why is that important? Well, what it says is the technology from 1902 is still serviceable, it's still maintainable, and can still be kept going. And Network Rail have priorities for obsolescence replacement of the relay interlocking and the power boxes that were built and commissioned in the 1970s. So something that is 120 years old can be extended in life for another 10 years, potentially 30 years, and probably a lot more than that. The relay interlockings from the 1970s are end of life and are priority for replacement because they can't be extended as much as that. And then the third thing I think which is relevant to this is that it's less than a mile to Sutton Bridge Junction, the Cambrian ERTMS and ETCS, which I will talk about in a few minutes. So there we have what obsolescence, the different time periods that apply to obsolescence. So getting to the boring bits, we have an international standard. The international standard was updated in 2019. We have a definition of obsolescence, and be clear, this is not about planned obsolescence that persuades you to buy a new Apple iPad every 2 years because they changed something on it that means you can no longer use it for what you bought it for. This is obsolescence caused by the transition of an item from available to unavailable, from the original manufacturer in accordance with the original specification, caused by some technical reason that prevents them being able to continue to support the product. So we have a definition. One of the things about the International Standard 2019 that I think is important to know is that it is now, firstly, it's an international standard. It is equally applicable to asset owners as it is to manufacturers. So the previous version, which was a guideline, was very useful for manufacturers, but wasn't very helpful if you were an asset owner. And so what I would commend to you if you are at the operator and asset owner end of the supply chain is that you have a look at the standard and see how that affects you and how to sustain your assets for the life that you expect to get from them. So I think we're sort of getting the idea that technology life cycles are incompatible. So if you look in rail, the pictures of a train, but it equally could apply to a signaling system. On the left-hand side, we see the components that we buy from the market. So we buy electronic components, of course. We buy sensors. We buy operating systems. We buy batteries. We buy relays. We buy all sorts of things from a component market that is targeted mainly at other markets. So it's aimed at the consumer market or the automotive market. and places where the volumes are very high. And those components typically have a 3 to 5 year life cycle. So from the first availability of a microprocessor to the end of life, it's 3 to 5 years. And I think if you're owner of a mobile phone, you will know exactly why. You would never buy a 5-year-old mobile phone if you could buy a new one that's cheaper and uses less power and lasts longer. In the middle of the drawing, in the middle of the scheme here, we've got the equipment that we expect to have a 10 to 15 year life cycle. Again, some of it we buy from the external markets, not directly aimed at rail, but we also have rail industry product from the suppliers within the rail industry who at least understand the requirements of obsolescence management, even if in the end their job is to make product and not necessarily to support it for the full expected life. Whereas we, as Alstom, as a maintainer and operator, and the asset owners of the equipment that we build and sell, expect our systems to have a 30 to 40 year life cycle. So that's normal. It's the limit on rolling stock is the fatigue life, corrosion, and that sort of thing. And similarly with signaling systems, we have various mechanisms that determine what the life cycle is, and we have to control those products so that we can sustain those items in use for the 30 to 40 year life cycle that our customers expect. So what goes obsolete? Well, obviously, we've talked about electronics. Electronics goes obsolete. We can also get obsolescence of mechanical parts. And in fact, the predecessor of IIOM, the Component Obsolescence Group in the UK, started in the nuclear industry and was worrying about things like relays and mechanical assemblies, not in 1995 electronics. We've got materials. The image there shows leaded solder. Leaded solder has been banned except in certain industries for the last 10 or 15 years, with a threat that actually it may simply not be not allowable in any new product from 2025. So leaded solder, those of you who know electronics will know that lead tin solder has all the ideal characteristics, and that there isn't a single ideal replacement for it. Every replacement for leaded solder is a compromise. Software can go obsolete. Why can it go obsolete? Not because you can't copy it 1,000 times, but because all the support tools that you need for it may go obsolete. So you think that the compiler for your software is a piece of software, but if it's licensed by the manufacturer, by the writer of the software, and the writer wants to discontinue it, he can discontinue the software license. He may discontinue the software key that you buy every year, which means that the compiler that you use for the software that you wish to maintain for the next 30 to 40 years may no longer be available. Again, test equipment, and then skills and processes. So it could be industrial processes, and it's the skills of people that actually know what we're talking about. And in the world of electronics, if you go back 40 years, an electronics engineer was someone who designed a piece of hardware and then wrote the software for it. Now, the hardware designers and the software designers don't even sit in the same building. They probably don't even sit on the same continent. So when we talk about items going obsolete, we're not simply talking about electronic components. So what does the international standard tell us to do when we have product potentially at risk of obsolescence? It says we need to identify the requirements of our customer. We need to identify the items in the project. We then have to do an obsolescence risk assessment of those items to see whether we think to see whether they are at low or high risk of becoming obsolete during their life cycle, and then select an approach. And you may have heard of reactive approach and proactive. Reactive means you wait till the obsolescence happened and then you treat it because it's unlikely to happen, or the impact of it happening is low. Proactive means you spend time now to reduce and mitigate the impact later. You prepare the obsolescence management plan that you should be managing throughout the life cycle the product or system, and that may mean that the obsolescence management plan is transferred from the manufacturer to the asset owner or the operator during the life of the product. And then, of course, you have the reporting and the monitoring of the components that are used in the system. So what's the obsolescence risk of ETCS and ERTMS? So let's have a look at some things that ETCS and ERTMS will inevitably require. Firstly, if we look at Trainborne systems, they're highly integrated systems that can contain a number of hardware and software components. So we've got complexity involving software. Control centers use proprietary hardware and operating systems. So if you're running Windows 10 as the operating system on the display on the operator's terminals, and you're running a Windows Server 2016 on the servers, at some point over the next 30 to 40 years, you can guarantee that you will not be supported on those. I think the end of life, well, Microsoft are very, very good and very open about the end of life of their operating systems. I think Windows 10 is about 2025. Those systems will have to migrate. The systems that run on those computers will have to be migrated to new operating systems. Inevitably and naturally, these are safety critical systems that require validation of each configuration. So when we change the configuration, we have to revalidate to prove that we haven't introduced new faults or new bugs and new risks to safety. So every time we change it, we have to revalidate, and that validation is not cheap. We use state-of-the-art electronic components. Why do we do that? Why didn't we simply keep the original EVC, European Vital Computer, that was designed 20 years ago? And the simple answer is that the customers demand that it has a smaller space envelope because they can't fit it in the cabs, as it can't fit it easily into the cabs. They want they want reduced power consumption because the auxiliary systems of the older trains may not have enough power to power up the ETCS Trainborne system, and of course they want the price to go down. All of those things encourage and force innovation on the manufacturers, who will develop new generations of their systems, and to do that they use state-of-the-art electronic components.
It would be nice if you could finish in about 1 or 2 minutes.
Yeah, sure. So we're nearly there. So cybersecurity will require a regular update of the software. ETCS baseline updates will again require regular update of the software. And of course, complex software will require periodic bug fixing. So we can say that both the likelihood and impact of obsolescence is high. Without going into the details here, you can see this is an ETCS Trainborne set of equipment, and you can see the interaction between a number of things. If you have to change the wheel sensor because the wheel sensor is obsolete, you will have to revalidate the system to ensure that the new wheel sensor correctly operates with the rest of the system. So it's a complex system. The first-in-class installation is a major investment for a specific rolling stock type. Therefore, you don't want to change that every 5 years. Spares and repair support really has to come from the OEM. And of course, as you talked about yesterday, GSMR will need to be replaced within 10 years. I think just a message, if you like, a message from history, and I understand from that Cambrian ERTMS was a pilot, and that it was expected that it would need to be upgraded. It's about 10 years old, and there has been an announcement that basically says the planned state-of-the-art digital signalling system, which will be implemented on Cambrian as an upgrade, will modernize the network, improving reliability of services and support the introduction of a new fleet being rolled out in December 2022, which basically says even if this is a major upgrade after 10 years of a system, and it had to be done in order to ensure that the new CAF DMUs could operate. I'm not going to go through. We'll leave the slides in, so when you download them, you can have a look at them. Some of the strategies that can be used during the design phase that companies like Alstom and others will use to ensure the long life cycle of the product that's sold. I think it's important to come to the summaries. So number one, you need, with your supplier, if you're the asset owner, develop and maintain an obsolescence management plan with support from your supplier. Ensure that the long-term service relationship, support relationship is fully defined. In the case of Alstom, for example, with our ERTMS implementation in Denmark, we have a 25-year support contract that goes with that. Build partnerships that respect the competence and resources of each partner, and recognize, I think, that contractual transfer of product data from supplier to customer is no guarantee of sustainability. If I send you the bill of material of an electronic card, neither you nor I will be able to make that card in 10 years simply from the data I supply today. And so to finish, to learn more about obsolescence management, I would encourage you to join the International Institute of Obsolescence Management. It brings together people from different companies and different business sectors. I can certainly say Alstom in the last 10 years has benefited from working with people from other industries and to bring in best practice. We have chapters in Germany, which covers Germany, Austria, Switzerland, India, UK, and the USA. International conference next year, a website and a YouTube channel. So there we are. That's that in a nutshell is the obsolescence challenge that we face jointly on ERTMS and ETCS.
Thank you, Stuart. I think that was really a very nice presentation, and it was a pity that you could not have 5 or 10 minutes more to also explain a couple of other things, because I think I cannot imagine that I'm the only one who would really know a little bit more about it. But it was really very, I think the word is elusive, but I'm not British, so it could be that I have the wrong word for it. I think one remark or maybe two remarks from my side. What we do at the moment, I mentioned it earlier, I showed a picture, I think, in the beginning of the conference, that we are looking now as the users for modularity and making sure. I think one of the most important thing about what we call the future reference architecture of the railways is to also make sure that we make a separation between the safety related part and the non-safety related part. I think that hopefully helps a little bit to mitigate the problems of obsolescence management later on. So maybe you can say something about that. That would already be quite nice. And I had a second question, but I'll come back to that once you have answered.
Yes. So I think on the question of safety, of separating safety and non-safety, that at least allows you to make to reduce the validation that's required on the non-safety part, and so if you've got obsolescence in the non-safety part, then you don't need to go through the same validation that you need to for the safety part. And certainly modularity is one of the keys to improving the life cycle, or extending the life cycle, the design and operational life cycle of product.
Okay, I'm very happy to hear that. Please also influence your colleagues from the design departments on that. And maybe a bit indecent question, but would you consider your obsolescence management department to be the money maker of Alstom? Or are you more faced with the fact that you have angry customers who cannot believe why it is so extraordinarily costly, and therefore you're more a cost center than a profit center?
Somewhere between the two, I think, is the answer to that. We certainly are in the business of selling obsolescence management services. I think what we would say is that obsolescence management doesn't come for nothing, and that the costs of obsolescence management need to be paid by the asset. And we take that all the way down the supply chain. So we don't say to our suppliers, here's a back-to-back contract, you will supply this spare for the next 30 years without question and without changing the price of it. we say to them in our obsolescence charter, we will discuss with you how you sustain this product over the life of the product to make sure that you have the revenues that enable you to manage it so that we can manage it and our customer can manage it. And I think if we recognize that flow of money through the supply chain, and we all respect that, then I think firstly, we can make our customers happier so that, we clearly need to educate our customers in obsolescence management, and we would encourage them to join the Institute of Obsolescence Management as well. Some of them already are. And I think they can then understand that, take Shrewsbury signal box, all you have to do is to replace the windows every 10 or 20 years. You don't have to spend money on it. If all you do in the next 10 years with an ERTMS system is to blow the dust off the electronics in the cubicle, it will not be still operational in 10 years' time. And that's the technology you've bought because you choose to take the benefits of that. If you wanted a basic railway signalling system, you could still use mechanical interlocking. So I think that would be my message, yeah.
Okay, thank you. Regretfully, we cannot spend too much time on it because it's terribly interesting. But I have two questions, and I promised the audience would have the priority, so we have to deal with them. Please try to answer them shortly. First question is from Martijn Huibers. Would you feel that backwards compatibility for COTS equipment would perhaps partially resolve obsolescence? At least there is a newer version that still fits, but that bespoke railway equipment might be more prone to obsolescence due to the lower volumes of the production?
The lower volumes is critical in this. The number of systems, the total number of ETCS cab systems that will ever be sold will probably be less than a day's worth of mobile phone sales. So you can see the impact of that. Backwards compatibility is great, but but is not always possible to do. We've upgraded DMIs, but when you upgrade the DMI, can you still run it with Windows 3 or DOS 11, 3.11 operating system on the new hardware? So backwards compatibility from COTS, it's what you get from the manufacturer. They're not going to do it for you unless they see a requirement for it.
Yeah, we are simply not the market for them. I can completely understand that.
Yeah.
Final question from Christopher Corey. Project in recent years had the trend to demonstrate the new computer-based interlocking is compatible or future-proof for ETCS implementation in 10 to 15 years. In similar thinking of buying an iPhone this year, that requires compatibility with the 7G mobile network in future. From the obsolescence perspective, the interlocking is about to commission, may have a new model in 5 years' time. How would you advise your customer? Maybe that's a very difficult question.
I'm not sure I can answer that one. And in fact, I think maybe that's a question for signaling experts, but it does come back to the issue of modularity, so that you actually have defined interfaces, which allows you so you know what interfaces you're working with, and that you haven't buried some of those interfaces in an unwritten specification in the software, for example. So I think, you need to talk to the experts about that, about how they will do it. But the principle is certainly important: modularity and definition of interfaces.